Welcome to today's Explainer. We're jumping right in today because our goal is highly specific and honestly incredibly practical. We are going to build a production-ready, entirely serverless generative AI application, and we're doing it right inside the AWS console. We're going to walk through a step-by-step guide to constructing a complete architecture using Amazon Bedrock, building it completely from the ground up. By the end of this, you'll know exactly how the magic actually happens. Okay, let's dive into this. So previously, our source material covered deploying this exact same application using the AWS Cloud Development Kit, or CDK, which is an automated, code-driven approach. But based on a lot of developer feedback, today we're focusing purely on the manual console deployment. This visual, step-by-step approach is just fantastic because it lets you truly see and understand every single wire you're connecting in the cloud. We're manually provisioning everything here, from IAM roles all the way to the front end, so you get a really deep, functional understanding of the entire stack. Now, before we start clicking around the console, let's quickly define the core concept of our build. It's called RAG, or Retrieval Augmented Generation. In really simple terms, RAG is the process of grounding an AI large language model with your own private external documents. And in our case, those are stored securely in an Amazon S3 bucket. So instead of the AI just kind of guessing an answer based on its broad training, it actually retrieves specific information from your data to provide accurate, highly citable answers. For our practical build today, we're using a fictitious company called AI Agent Insure, and we'll be loading its company-specific markdown documents right into the cloud. To make sure we don't get lost in the AWS ecosystem, here is the blueprint for our build. We'll look at the chatbot architecture, set up the AWS foundations, build the AI knowledge base, connect the serverless backend, deploy the React frontend, and then finally test and tear it down. Let's start with Section 1, the architecture of the chatbot, focusing specifically on our serverless design. And this brilliantly illustrates exactly how each AWS service maps directly to our full-stack architecture. We are using Amazon Bedrock as our central AI engine. For the brain that's actually generating our text responses, we're relying on Amazon Novalite. Then, to mathematically embed our documents so the AI can actually understand them, we use Titan Text Embeddings VQ. Amazon S3 handles both our raw document storage and our vector storage. From there, we bridge the gap to the user with a Python-based AWS Lambda backend, an API gateway to service our endpoint, and a React frontend for the user interface. It really is an incredibly robust, completely serverless stack. Moving to Section 2, setting up our AWS foundations, specifically IAM and S3. So the source material details these critical first steps. You absolutely have to create specific identity and access management, or IAM, roles before you touch any of the AI tools. You know, IAM permissions are kind of like the vegetables of AWS. Nobody loves setting them up, but they are absolutely essential for a healthy app. You'll create one role for Lambda to execute and invoke the Bedrock model, and another custom trust policy role for the knowledge base to read from S3. These are least privileged policies, meaning they only grant the exact permissions needed, nothing more. Once that security is locked in, you just create a general-purpose S3 bucket and drop in your Markdown asset files. For this build, that's exactly 11 specific documents for our fictitious AI agent Insure's company. Now for Section 3, building the actual knowledge base using Amazon Bedrock. Configuring the knowledge base in the console is actually surprisingly streamlined. First, you point it to Amazon S3 for vector storage. What's just absolutely fantastic here is that the console automatically creates the vector index and bucket for you right under the hood, which saves you a ton of manual configuration time. Next, you apply the parsing strategy, and the default parser works perfectly for our Markdown documents. And then you select Titan Text Embeddings V2 as the embedding model. Finally, once all that data is synced up, you just set the generative AI model for the knowledge base to Amazon Novalite. Section 4 takes us to connecting the serverless back end, specifically our AWS Lambda setup. So the crucial point is how we configure this Python 3.12 Lambda function. We have to inject two very specific environment variables. The first is the knowledge_base_ID, which you can grab directly from your Bedrock console. The second is the foundation model_ARN. You can point this one to Amazon Novalite, or because the architecture is so flexible, you could easily swap this out for another model if you wanted to, like Anthropic's Claude 3 Haiku. Basically, these variables tell our Python runtime exactly which AI resources it needs to retrieve from and generate with. Now, I really gotta highlight this critical best practice tip, which comes straight from the manual deployment guide. When you create a new Lambda function, the default timeout is a mere 3 seconds. The guide explicitly warns us to increase this timeout to at least 30 seconds, or ideally up to 3 minutes for heavier tasks. If you skip this step, your application will almost certainly break and throw timeout errors, simply because complex Bedrock generation calls routinely take way longer than 3 seconds to complete. Next up, we have to expose our Lambda function to the web, and we do that using Amazon API Gateway. You'll create an HTTP API and set up a post route specifically for /chat that integrates directly with your Lambda function. Then, you absolutely must configure CORS, that's cross-origin resource sharing, so your front end is legally allowed to talk to this backend. You'll allow post methods and content type headers. Finally, and honestly this is an easy step to miss, you've got to ensure auto-deploy is enabled on your API stage, like the default or prod stage. Without auto-deploy, you just won't generate a usable invoke URL for your front end to hit. That brings us to Section 5, deploying the React front end utilizing S3 static hosting. The provided GitHub repository actually has this React app pre-built for you, but going through the deployment checklist is vital. First, if you're building from scratch, you scaffold the app and install the necessary node dependencies, things like Tailwind CSS. But the most important step is opening your .env file and pasting in that exact API gateway invoke URL we just generated. You can run npm run dev to test it locally on localhost 3000. Once you confirm it's all working smoothly, you build the app and deploy the compiled distribution files to an S3 bucket configured for static website hosting. What this means is your entire front end is served serverlessly. 0 web servers for you to patch, scale, or manage. Pretty cool, right? Now for our final section, testing the whole system. And, just as importantly, tearing it down to clean up our resources. Let's move to and see how this builds during a live test, to see how this all comes together. Step 1. The user sits at their React UI hosted on S3 and asks, what is AI agent ensure? Step 2. That request goes right through our API gateway post route to our Python Lambda function, which uses the Bodo3 library to execute Bedrock's powerful retrieve and generate method. Step 3. Bedrock pulls the context from our S3 vectors, generates an answer using Nova Lite, and sends it back. Our UI then beautifully displays not just the generated response, but also the exact S3 document source chunks as citations. It is a fully integrated, seamless loop. But wait, we aren't quite done yet. The source documentation includes a highly specific manual teardown sequence. If you're just testing this architecture, you really must follow this to avoid any unexpected AWS charges. First, delete your Bedrock knowledge base and its data source. Next, and this is crucial, you have to manually empty your S3 buckets, the vectors bucket, the document bucket, and the front-end bucket, before AWS will even let you delete them. It's a bit tedious, sure, but it saves you from a surprise on your monthly bill. Finally, delete your Lambda function, your API gateway, and those custom IAM execution rules. By walking through this manual console deployment, you've seen exactly how to orchestrate S3, Bedrock, Lambda, and React into a highly capable, highly secure, completely serverless RAG application. Now that you understand the mechanics of giving an AI-specific citable context, the most exciting part is applying it to your own data. So, my question to you is, what custom documents will you load into your knowledge base?